Hello everyone, my name is Anas Ahmed and today I'm going to present to you my case study for the subject TMI 6323 for the subject malware and intrusion detection. So our core focus today is proactive malware and intruder detection, analyzing how we can interpret modern digital threats before they execute. Okay. Based on statistics reported in early 2026 by the Royal Malaysia Police and the Commercial Crime Investigation Department, scam activities in Malaysia has seen a significant accelerating trend early in the year. Our primary problem statement revolves around the shift in adversary tactics. Victims have recently lost all their savings after receiving fake SMS payloads sent from hackers. These fraudulent messages are engineered to perfectly mimic the genuine SMS sent from local Malaysian banks, rendering traditional signature-based security perimeters largely ineffective. After we know the problem that we have, now I'll be explaining how attackers do or like execute their tactics to hook the customers. So, to properly assess the risk, we must explain how it happened. So, first thing, the threat actor conducts a ring conscience attempting to get the bank's customer details. This thing can happen by getting by social engineer or maybe by finding a loophole in database of the bank side. From there, they compile a target list of contact details and generate a genuine looking fake SMS message to hook the customer. What makes this a particularly dangerous is that the attack is engineered via a type of reverse social engineering strategy, which is also known as inbound trap. Instead of using the typical malicious hyperlink that could potentially be caught by either mobile browser security feature or firewalls at network level, the attack is carried out by using a locally managed telephone number. Because the user initiates the call, once an unsuspecting vulnerable victim dials the phone number, an outbound security alert will not occur. This bypass allows the victim to connect with a trainer fraudster who has been instructed to obtain a secondary authentication tokens, dynamic TAC OTP codes, or sensitive account credentials directly from the victim. So I propose after research on the web, I found out there is a website that can help user to identify this kind of, I can say, a scam. So, to establish a proactive malware and intruder detection capabilities, I must utilize specialized threat intelligence tools for analyzing phishing SMS and emails. For this case study, I introduce Fishbowl, a robust online threat intelligence platform uh, that offers a range of tools for investigating SMS, WhatsApp, and Telegram scams, including an extensive analysis of textual content. The platform uses an assortment of heuristic engines, natural language processing, and sets of behavioral based sentiment analysis to dynamically analyze suspicious incoming messages in real time. It operates by distinguishing between legitimate versus non legitimate text messages through a static database online on file. Furthermore, it analyzes the structural conversations and linguistic structure, as well as the contextual elements embedded within the text payload. This combined analytical technique enables a security analyst to provide an instant level of transparency regarding potentially complicated zero-day social engineering schemes before they lead to an unintentional interaction by an end user with a fraudulent source. So we have did an case study incident analysis with one of the fake message that had been given in by our case study. Okay, so the case study, our specific message confirmed is an SMS messaging phishing attempt through the evaluation of the content. Okay, the raw message content submitted for the program verification was started as the follows: RM0 bank TQ for using your card ending number. For the much number is 1360 and not to reform, please call this current number. This information was structured as a critical alert designed in a way to provoke an instant thought process in the recipient that a large value of transaction had occurred without their authorization. So then we did test this message, and as you can see in this picture, the website did alert and give like an automatic heuristic extraction of the text block by the automated system. The threat intelligence model assigned a new critical classification value to the incident payload. The scanner returned a final decision of malicious, flagging as a potential fraud and is detected as smishing. The engine assigned a confidence score representing an 85% risk possibility index that it can state with a high level of confidence that this email represents an active smishing threat vector. And the payload heavily uses reverse social engineering tactical types of behavior. Ultimately, this establishes a false inbound channel for individual where the victim is psychologically manipulated into a contacting infrastructure that is entirely controlled by an adversary. Now we're going to break down into the reveals of the mechanics of how this payload circumvents human logic. The main psychological mechanism being used in this payload is based on an artificial sense of urgency and panic tactics. In addition to injecting panic through high pressure wording in the instruction such as please call immediately, the adversary is attempting to evoke a strong sense of emotional panic by providing the recipient with a large unauthorized transaction amount of 1,360 ringgit. The attack is explicitly designed to pour through a rational thinking and cognitive barrier functions in the order to exploit victims who do not use logical anomalies. Okay, next we'll be talking about the defensive protocol that we can suggest to customer or any user or any victim who had came passed by this kind of I can say scam. Okay, so first there should be absolutely no contact made with the call number or sender of the incoming text. Engaging with the message indicates to the perpetrator that there has been a response to the illegally used line. Second, users must verify through trusted channels. If they are a legitimate customer, they must confirm transaction history only at the official trusted number listed on the back of their card, or check the latest transaction directly in the bank app. Finally, the caller ID number, such as the number that has been given in the fake SMS message listed in the payload, along with the text, needs to be reported, cataloged, and secured with the regional enforcement reporting sites. This means filing a report with the NSA or through local commercial crimes like the PDRM so as to protect all the other potential victims. So after we've been discussed about the ca- the how to secure or how to the proposal solution for missing messages. Now we'll be going for our next part, which is our reactive security. So the core problem we have here is today is that standard banking authentication systems are highly reactive rather than proactive. Currently, static variables are presented to the user such as identity of a recipient hacker and a monetary value, accompanied simply by a binary approve and reject controls. As defined with the reactive model, this base application system makes highly fragile security assumptions. It operates on the assumption of intent hoping that the finger click on the approve button belongs to a legitimate owner willing to authorize the transaction without the coercion in a safe environment. It relies entirely on a post-event remediation, where emergency account freezing via skill switch occurs only after the funds have cleared from the account into a mule networks. Finally, it suffers from a lack of environmental telemetry. There are no dynamic local components installed on the device to monitor the execution context of the host operating system, leaving no way for the system to determine if a remote data stream is currently capturing or manipulating the application in a real time. Real time. So, for a solution for that, we find something called risk orchestration. So it's like this. To We must modify the banking approval app to become a proactive rather than reactive. The proactive architecture utilizes the Lexis Nexus. It's a website. It's the kind of a company where they have the kind of solution. So it's the fraud identity. It's one of their products. It's called Lexis. It's called Lexis Nexus Fraud and Identity Suite. Combined with another platform with called risk orchestration. This allows banks to programmatically change to dynamic and personalized authentication path. This orchestration engine acts as a real-time middleware proxy layer. When a transaction is initiated, the client application collects local device posture anomalies and device identification numbers through an integrated threat matrix SDK. This metadata payload is pushed to the risk orchestration layer, where a rule engine will cross-reference the destination data with a global risk indices and regional regularity registers to check whether the beneficiary accounts have been named on a PDRM or a scorecard is generated that allows show a risk index of transaction on a scale of 0 to 1000. So for an example of how we want the proactive solution to be, so we have made a change in the, or like maybe like a proposed solution for how it will be look like if we implement the proactive solution. So by committing the risk scorecard, we can primitively stop malicious or undesirable behaviors prior to them being executed through a redesigned proactive user interface. If the orchestration engine calculates a moderate or high threat index, the static yellow approve button will be modified at the structure level or disabled. The application will force the user to go through a localized friction by implementing a secondary combination requirement, such as local biometric authentication. This requires the user to submit either a face recognition or a fingerprint scan. Additionally, the contextual AI warnings will be displayed, providing explicit alerts based on the reason for the risk via the risk engine. Like, for example, the app will warn the user, warning this account number has been flagged for abnormal incoming funds velocity within the last 30 minutes. By implementing this dynamic verification, path and obtaining ongoing behavioral telemetry natively within this client app, financially solutions establish a multi-layered defense ecosystem that protects user assets and ensures the integrity of the digital banking system. That's all for our case study. Thank you for watching.